Morgan. I'm Morgan.
Hi.
How are you doing?
Good, how are you?
Good. How'd math end up going for you last semester?
Alright.
Yeah.
Not great, but yeah.
So, are you into trig now?
Yeah, and I sent you a worksheet. I don't know if you got it yet, though.
Here, let me pull up my email. Not yet. Can you verbalize one or two problems while we're waiting for it to be received?
Yeah. Or let's see. Well, I'm working with like cosine and tangent and stuff like that.
Okay.
So we could do like one of them's find the exact value of each trigonometric function, and it's
That's the perfect place to start with trig. So give me one up.
it's tangent 45 degrees.
Okay. Now, are you still completely in degrees, or are you also in radians?
Well, we have worked with radians.
But so far, they're giving you stuff in degrees.
Yeah.
All right. Let's go back to the two triangles that I have been teaching you about for probably 3 years. 45-45 right triangle and the 30-60 right triangle. Do you know the dimensions on these triangles? Because that's the key to memorize.
Yes.
What's the dimension opposite the 30?
Opposite the 30 is it 1?
What's opposite the 60?
The square root of 3
And the hypotenuse?
is 2.
Opposite the 45?
1.
Now, some schools, they might actually give you the 45-45 as this. And notice that that is merely a factor of square root of 2 bigger than this.
Mm-hmm.
Do you know which one your class uses? This one?
Yeah. No, we use the other one.
The first one? Good.
Yeah,
I like the first one. There's a reason for using the second one, but it makes it more confusing, actually, I think. All right, so as long as you have these two triangles memorized and you know SOHCAHTOA, then you should be able to figure out all of your major angles. In other words, 30, 45, and 60 for all 6 trig functions. So tangent is what? So we're looking for the tangent of this 45-degree angle right there.
So it's opposite over adjacent.
So in this case, what is that ratio?
Do we use
The opposite side over the adjacent side.
Oh, so 1 over 1. So it's just 1.
Now notice that all angles have 2 adjacent sides. But in SOHCAHTOA, when they say adjacent, they mean the adjacent side that is not the hypotenuse. So the adjacent side to this angle that I have circled here is this side right here.
Okay.
And it's not ambiguous. It's always the side that is not the hypotenuse. Okay, so let's do a whole bunch of them. Tell me what the sine of 30 degrees is.
Oh, so would it be 1 over 2? So 1/2.
What is the cosine of 30 degrees?
The square root of 3 over 2.
What is the tangent of 30 degrees?
So 1 over the square root of 3.
Okay. Now this answer here needs modification because it has an irrational denominator. You never want to give that answer. It's the same number as after we rationalize it, but how do we rationalize that?
Well, yeah, you have to take the square root, or multiply it by 2.
No, you multiply it by square root of 3 over square root of 3, which is the number 1. In other words, I can multiply any fraction I want by the number 1 without changing its value. So I'm not changing its value, but what happens is you end up with the square root of 3 in the numerator, and now you have a real number in the denominator, or not a real number, a rational number. So this answer here is the preferred mathematical answer to this one here. Even though if you were to put it into a calculator, you'd get the same exact number. It's just you don't want an irrational denominator. Okay? So what is the cosine of 60 degrees?
Is it 1/2?
Notice that the cosine of 60 is the same as the sine of 30. And it's always going to be the case where 90 degrees minus, in other words, the sine of 20 is the same as the cosine of 70. Okay? What is the what is the sine of 45 degrees?
1 over the square root of 2.
And change that into in other words, you're never going to see that answer on a multiple choice, and you don't ever want to put that answer in because it has the irrational denominator.
So the square root of 2 over 1.
Square root of 2 over 2. And it's always like that. In other words, the square root of 1 over square root of 5 is square root of 5 over 5. And so forth and so on. But the way you get that, the way you get it is by multiplying top and bottom by square root of 2. And then that's how you get the 2 in the denominator. All right. So I feel like you have a good understanding of how to figure out the first quadrant angles. Because all you need is these two triangles.
And I think maybe my
Your
worksheet.
email probably got here. And the first one titled Image. Is that the one we want to go to? Whoa.
I think I actually sent them in a different format.
Well, the only thing wrong with this is it appears to be a little blurry. We can probably make it out, and if we can't make it out, you can tell me what the numbers are.
Or I can just resend it really fast, because it only took like a second.
Okay, let's see. Hold on. Let me open the second one, and let's just see if it's...
I think I accidentally sent them small instead.
Okay. Well, it's not that so much. This one Yeah, it's pretty blurry also. So if you do have a different way to send it, it looks like your resolution might not be at what kind of camera are you using? An iPhone or a,
Yeah, but it normally works. I think it was
yeah,
just
the
my
iPhone
phone.
has high resolution, so you may not have it set on 8 megapixels when you
Well, it asked if like how big you want to send it, and I said send small.
okay, so
So
why
I'm
don't
gonna
you
send
try
it again and just normal
send it
size.
big, and I can
Yeah.
change the size on my end if it needs changing. So,
All right, it's just sent. So.
okay, let me in fact put these in my recycle bin. All right, while we're waiting for that, hold on, maybe it is here. It is. Yeah, that solved the problem. Okay, did we start at 1?
Yeah.
Okay, so let's just go through these quick. What's the tangent of theta? Okay, you got it right there, 12/9. Is that your writing? So,
Yeah, that's my writing.
so you did one of them and we need to do the rest. Okay, what's
Yeah.
the cotangent of theta in this triangle?
Oh, so it's adjacent. So is it 10 over
No, I'll tell you the
6?
It's the way I do. I kind of treat trig as your 3 primary trig functions: sine, cosine, and tangent, and then your 3 secondary trig functions as the reciprocals of each. So if you ask me the cotangent of theta, I'm going to figure out what the tangent of theta is and flip it.
Oh, okay.
Okay, so what's the tangent? What's the tangent of theta?
Oh, so 6 over 10.
No, remember it's opposite over adjacent. This is the hypotenuse. The
Oh, right.
the hypotenuse is always opposite the right angle.
Oh, so it's
just
6 over 8.
Right, so just because they have it oriented backwards,
Right.
make sure you figure out which is the hypotenuse as your first step. So if the tangent is 6 over 8, the cotangent is what?
8 over 6.
Yeah, or 4 over 3.
Okay.
Okay, what's cotangent of theta here?
So 9 over 3 square root of 10.
No, you said it. No. First of all, what's the tangent of theta?
Oh, 3 over 9.
So what's the cotangent of theta?
9 over 3.
Okay, and that's 3. Always make sure you
3.
Always make sure you simplify it. Okay, what's tangent of theta?
Is it so 15 over 20?
Okay, which is
3 over 4, 3/4.
okay. All right, I love problems like number 5. Let me bring my notebook up because you can make them very, very easy. I don't want to get rid of that yet. These are your classic trig questions. They give you the value for one trig function, and they want you to find the values for the other. And all you have to do is draw a triangle. Okay? If they tell me the sine of theta is 12 over 3, well, my first step is I draw any triangle, label theta, very important, and start dimensioning this triangle. What is this dimension here?
12.
What's this dimension?
13.
And now use the Pythagorean theorem to figure out your third dimension.
Okay, so is it?
So you want to get really good at doing the Pythagorean theorem to solve a triangle. It's something you have to do a lot of in trig. So rather than starting from this and having to do all the complicated algebra, I would suggest you start from these two steps and memorize these. C is always the hypotenuse. It's always equal to the square root of a squared plus b squared. You need to memorize that. The other thing is to memorize how you solve for a side. Well, if we solve this primary Pythagorean equation here, a is going to be the square root of c squared minus b squared. And likewise, b is going to be the square root of c squared minus a squared. So memorize these two on how to solve for the third side of a Pythagorean triangle. So we're solving for one of the short sides, which is either a or b, whatever you want to call it. So plug it in. And notice that they all begin with square root of. I can't emphasize that enough to students, because so many students want to say C is equal to, and they forget the square root of. So in our case, A, we'll call that A, the short side, one of the short sides, is equal to what?
Is it 12 squared? Or
C is always the hypotenuse. So it's square root of. First words always want to be square root of.
13 squared minus 12 squared.
Which is 169 minus 144, which is 25, which is 5. And in fact, this is the second smallest perfect Pythagorean triangle. You're familiar with a 3, 4, 5? Well, this is the next one up, the 5, 12, 13. Okay? So, these are important here. I would definitely try to memorize these so that you can quickly solve any Pythagorean, any right triangle. By solving it, I mean when they give you two sides, you can solve for the third. Okay? So now that we have the fully triangle dimensioned, what's the cosine of theta?
Cosine. So 5 over 13?
Yes. What's the tangent of theta?
12 over 5.
Okay, that's what you want to get good at. That's just, it's going to take practice and drilling and memorizing, but the way you're going to memorize these things is by just doing a bunch of these. Okay, so this one here, they want the cosine of theta, and they tell us the tangent of theta is root 7 over 3. So it's a different triangle, but I don't have to redraw my triangle. I'm still going to use a right triangle. I'm going to label theta, and now how do I dimension this?
So the opposite is square root of 7. And then The adjacent is 3.
Now quickly figure out the hypotenuse.
Oh, so it's going to be the square root of 7 squared plus 3 squared.
You said plus 3 squared?
Yeah.
Okay. What's this number?
1 second.
First of all, what's this? Don't use your calculator for the moment.
Oh, it's just 7.
Okay.
9, so 16.
Okay. What's the
So
square root of
4.
16? Exactly.
Okay.
Okay. So even though we sometimes end up with integer answers, when you're solving a Pythagorean theorem, it still always starts out square root of. It just happened that this ended up being square root of 16, which converted to a number.
Mm-hmm.
All right.
Okay.
Cool. All right. Let's go down to the next one here. And that's all we're going to do on all of these. Hold on. Let me move that up higher. Use the same triangle. In other words, I don't have to make this triangle be even close to the dimensions. I don't have to redraw it every time. I don't care whether it looks proper or not. Is all I care about what its 3 dimensions are. So if the cosecant of theta is 5 over 4, which sides are that? Cosecant is reciprocal of which one?
Is it sine?
Let me show you how to memorize this. Because if there's anything you want to memorize, it's this stuff here. I know it's just the beginning of trig, and that's why you're using your book, but you want to have these down pat. Notice that we have our 3 primaries, sine, cosine, tangent, and we certainly know that cotangent is the reciprocal of tangent, right? That's easy to remember. So the only difficult ones to remember are the sine and cosine. In other words, does sine go with cosecant or with secant? And does cosine go with secant or cosecant? Well, notice that each one of these have a co in it. There's a co there, and there's a co there. So knowing that, and in fact there's a co down here. So memorizing your reciprocal identities, that's all you need to do. And of course, the reverse is true. In other words, cosecant is also the reciprocal of sine. But you don't need to memorize all 6 of them, because if you memorize these 3 relationships, that'll get you by. So if cosecant is 5 over 4, what is the sine? And you don't need to do it this way. I just am going to kind of encourage you to try to work with your 3 primary ones. Those are the ones that are on your calculator. Do you have a TI-84 or do you have a Inspire?
Yeah, that's TI-84.
Okay, because on the new Inspire CX, they actually have all 6 of them on there. But, so, let's figure out, in other words, let's translate everything into sines and stuff instead of working with cosecants. So if the cosecant of theta is 5 over 4, what is the sine of theta?
4 over 5.
So now dimension this triangle for me.
So the opposite is 4, and the hypotenuse is 5.
And this side here?
Is A.
And what is it? In other words, our next step here is to put a dimension on that. So it goes the square root of what?
It's going to be the square root of 5 squared minus 4 squared.
There you go. Okay. That's 9. So that's 3.
3. Okay.
Now, notice that if we were super aware of the 3, 4, 5 triangle, the moment we see a 4 here and a 5 hypotenuse, we don't have to go through this calculation. We know that's 3. In the same way that we knew 5, 12, 13. In other words, if you're given a triangle and you see a 5 and a 13, you know the other side's 12. Or if you see a 12 and a 5, you know this side's 13. So it's quite useful to recognize these two triangles. It saves you from doing a lot of math.
Okay.
Okay. So now that we know that side is 3, they want to know what the secant of theta is.
5 and 5/3.
Yes. Okay?
Okay.
And the next one is the cosecant of theta is 25 over 7. So dimension this triangle for me.
So opposite is 7 and the hypotenuse is 25.
And this side here.
So then A is gonna be the square root of 7 squared minus 25.
No, remember it's always the largest side squared first.
Oh, okay.
Notice that if you took 7 squared minus 25 squared, you'd have a negative number.
Right, okay.
And the moment you see a negative number, you know you've done it backwards. Okay? Now, this is 625 minus 49, which is 576. Which happens to be, the square root of that is 24. And the only reason I know that is because this is like the 4th biggest perfect Pythagorean triangle.
Wow.
Even though most people don't have this memorized, only because I'm a math tutor do I have that memorized. Most people would not.
Okay.
So most people would have to use the Pythagorean theorem. And
Okay.
I don't know what the next biggest one is. It is worth noting that when I say a 3, 4, 5 triangle, I mean all multiples of that also. In other words, if you see this one's 6 and this one's 8, I know that's a 3, 4, 5 triangle. This one has to be 10. In other words, this one's just twice as big as this one. So you'll notice a lot of these trig problems are based on these perfect Pythagorean triangles. So it's really quite useful to have some of them memorized. It saves you doing a lot of math.
Okay.
Okay, so if our triangle is, 3, 4, 5, what is the cosecant of theta? I'm sorry, what's the secant of theta? Oh, you already answered that.
Yes, 7.
Sorry,
Okay.
I got carried away. Okay, so over here, we're on to the next one. Okay, so we did 9. All right, let's see. You want to give these a shot looking at the triangles or not looking at the triangles?
I like looking at the...
For the moment, that's fine. At some point, as long as you can recreate these triangles on yourself, then it doesn't matter if you look at them or not.
Right.
As long as you can draw these from memory. So what's the tangent of 30?
The square root of 3 over 3.
Okay.
I have the first, 9, 10, 11 from what we did earlier.
Okay. So 12. That's the secant of 45. Try to memorize what the reciprocal of secant is. You know it's either cosine, and it's cosine because it has to have a co in it. Right? Okay.
So then I don't know, how do you find the opposite of that?
Well,
Or how do you change that into
you
cosine?
can take either angle. They're each 145. So what's the opposite of the 45? It's 1 over root 2 would be cosine is 1 over root 2. So secant is what?
Is it 2?
Flip it. We're not rationalizing it.
So root 2?
Just root 2 over 1. Or just root 2.
Okay.
Okay. Now, remember when I said some school systems draw their 45-45 like this?
Mm-hmm.
The reason they do it is because you're usually taking sines and cosines, and if you take the sine of 45, you immediately get that. So you don't need to rationalize it. So they feel like it makes it a little easier for the students. Of course, the problem is if you take the secant, which is 2 over root 2, now you have to rationalize that, whereas you don't if you use this model here. So I prefer this 1 root 2. For one thing, it's easier to remember.
Mm-hmm.
Okay, so we do have some radians here. Let's talk about radians for a second. What's pi over 4 in degrees? If you don't know it by heart,
I don't know.
it's always the number that when multiplied by the denominator is equal to 180.
Okay.
Okay, so pi over 3 in degrees is what?
60?
Uh-huh. Pi over 6 is what?
30?
So that's the way to memorize the easy ones. The pi over 4, the pi over 3, and the pi over 6, which come up a lot. And of course, pi over 2 is what?
90.
Uh-huh. Okay, so it's, even though you can apply the conversion formula, which is 180 over pi, and the pi's cancel, and you get 45, it's sometimes easier to just do it the way I just showed you, where you know you need a number here that's going to multiply by that to equal 180. And it kind of makes it easier memorizing these. So we can think of the sine of pi over 4. Do you prefer to, in other words, learning radians is a little bit like learning a second language. You can either always be doing the translation in your head and solving it, or you can learn to think of 45-degree angle as pi over 4. In other words, I could label these as pi over 4. I could label this one as pi over 6. I could label this one as pi over 3. It just kind of depends on how you want to do it. Being that you're relatively new to trig, you're probably more comfortable converting stuff to degrees and going from there. Yes?
Yeah.
All right. So sine of pi over 4 is sine of 45. What's that?
So, isn't it just 45 degrees?
Remember that when we take the sine of an angle, we get a number. So you're never going to get an angle.
Oh, so is it like a decimal number?
You get a ratio. Trig's all about ratios. Sine is opposite over hypotenuse. Well, in this triangle here, In other words, this problem is no different than all the ones we've been doing. It's just we've converted the pi over 4 radians into a degree. And now we're doing the same thing we've been doing.
Okay, so it's 1 over square root of 2.
Which rationalizes to?
Square root of 2.
Over 2. Don't forget that bottom 2.
Oh, yeah, over 2.
And let's make sure you know how we got it. If it's 1 over root 2, you can only multiply a number by 1 without changing it. So my 1 is that, and that produces, multiply the numerators, multiply the denominators.
Okay.
That times that is that.
Right.
All right. So what's the cotangent of, what angle is that?
It's 30, well, it's 30 degrees and it's cos, or is it tangent? Yeah. So it's tangent 30 degrees. So then it's
cotangent of 30 degrees.
Right.
Okay. So looking at this triangle here, you can either think in terms of tangent and flip it, or you can think in terms directly of cotangent. What are you more comfortable with?
Tangent.
So what's the tangent of 30 degrees?
1 over square root of 3.
And notice that it doesn't behoove us to rationalize that, because our next step is to flip it.
Okay.
Right?
So
in other words, we're not looking for the tangent of 30 degrees, we're looking for the cotangent. So we're going to take our tangent answer and flip it.
Okay. So then it's just going to be
Yeah.
square root of 3.
Notice what would have happened had we gone to all the trouble to rationalize that. We would have had square root of 3 over 3, and now we flip it and we get 3 over square root of 3, and we got to rationalize it again.
Right.
So you end up with square root of 3. So don't rationalize your answers until you are done with the problem.
Okay.
Okay? Because sometimes you won't have to.
Do you think we could go on to the next page since we only have like 20 minutes left?
Okay?
Let's see. We could go to do like a few in each section.
All right. It's worth doing non-first quadrant angles.
Okay.
Okay? Because this is a key part of trig here. However, once you've figured out how to do all your first quadrant angles, there's a very simple method that I like to teach people, and it isn't necessarily the same one your class taught, but it probably is close. You need to label your unit circle in 2 manners. All students take calculus. Tells us what the plus or minus sign is on every trig function in each quadrant. In other words, the A means that all 6 trig functions are positive in the first quadrant going from 0 to 90 degrees, second quadrant going from 90 to 180, so forth and so on. In the second quadrant, the only plus trig functions are sine and, of course, its reciprocal. If sine is positive, its reciprocal cosecant has to be positive also. In the third quadrant, only tangent. In the fourth quadrant, only cosine. Okay? Now, the other 3 things you need to memorize are how to take a second quadrant angle and convert it to a first quadrant angle. And then you do all your work with first quadrant angles. Now that's it. That's all you have to memorize, is those, what you see on the picture there. So, tangent of 300 degrees, which quadrant is that in?
The C?
Well, that's
Or
not,
no,
it's not
C.
called quadrant C. It's actually, it's 1, 2, 3, and 4. Those are your 4 quadrants. They go counterclockwise. So we're in quadrant 4.
Mm-hmm.
In quadrant 4, we're going to use this formula right here. So what is the equivalent first quadrant angle that we're interested in?
I have no idea.
360 minus 300.
So 60?
Uh-huh. So the next step of the question is, what is the tangent of 60? And if we went back and looked at that triangles, our 30-60 triangle, we would discover it's square root of 3. Now, that's the answer, only I have to make sure that the plus or minus sign is on it. Well, in the 4th quadrant, what is tangent? Is it plus or minus?
Plus?
No, it's only plus here and here. In other words, the A means everything is plus, but if it's not listed with one of these letters, it's negative. In other words, tangent is negative in the 2nd quadrant. It's also negative in the 4th. So I have to put a negative sign in front of that. So the tangent of 300 degrees is equal to negative root 3.
Okay.
And that process works. I just looked at the top instructions and realized that that's not what you're doing here. They want you to use your calculator.
Mm-hmm.
All right. Even still, what I just taught you is incredibly critical for learning and understanding trig. The process for manually figuring these out is what we just went through. And it requires you to only memorize things in groups of 3. I know that they're going to give you, if they haven't already, this giant unit circle. They break it up, and they want you to memorize all 6 trig functions for every spot divided into 16. That's crazy. Nobody can do that. The way to do it is to memorize this stuff in groups of 3. In other words, anybody can memorize all students take calculus. And the only other things you have to memorize is this 180 minus theta. Well, the 3rd is the opposite of that, theta minus 180. And the 4th is the same as it, only with a 360 instead of a 180. So if you can memorize what you see on the page here, you can calculate manually all of these trig functions that are multiples of 30, 45, or 60.
Okay.
For doing these 2 problems with a calculator, your calculator has a tan on it, so you can just type, make sure you're in degrees, not radians. Okay, so you can type tan 300 degrees. It's going to give you square root, what did we come up with, square root of 3? Negative square root of 3. So its answer, if you have your calculator and you do that, you're going to get something about like that, negative 1.71.
Yeah.
Okay? Now, how do you do the reciprocal ones? Since your calculator doesn't have a secant key, what key are you going to push?
Cosine?
Yeah, the cosine of 188. What's your calculator tell you that is?
Negative 0.99.
Now, how do we figure out what the secant of 188 degrees is?
Isn't it just the opposite?
It's not the opposite, it's the reciprocal.
Reciprocal.
So, do you have a reciprocal key that will immediately tell you what the reciprocal of that number is? That's what you want to do. If you don't have a reciprocal key, take 1 and divide it by that number.
Okay.
I think the Texas Instrument 84 does have a reciprocal key on it, if I remember right.
Maybe.
I don't use one anymore, but you don't really need it because you can just take 1 divided by your answer.
Okay.
In other words, once you come up with the cosine of 188 degrees, remember that's not your answer, that's the reciprocal of your answer.
Mm-hmm.
So 1 divided by that is going to be also very close to that number.
Right.
It's going to be like it's going to be like negative 1.001.
Mm-hmm.
Okay. Let's go on. All right. Now, this set of questions here, 19 through 22, are all first quadrant.
Okay.
So, you understand the concept of inverse, arc sine, arc cosine? If I say the sine of 30 degrees is equal to 1/2, which it is, then the inverse sine, or arc sine, what does your class call it?
Oh yeah, just inverse sine.
That is true. If that is true, it means this. Notice that if we take the sine of an angle, we get a number. Well, if we take the inverse or arc sine of a number, we get the angle. That's all it means. It's an inverse relationship.
Okay.
Okay? So we're looking for the angle that the cosine of that angle is 1/2. What is that angle? Are you supposed to be able to use your calculator in this section?
Yeah, I think so. We kind of
You don't want to, actually.
No. I mean, we learned how to do it without the calculator.
You want to be able to do this based on these 2 triangles. Let's look at these 2 triangles again. How are they dimensioned?
What? Oh, yeah, 1 square root of 3 and 2.
This one?
1 square root of 2.
So, cosine of theta equals 1/2. Which angle, is it the 60 or the 30, is the cosine of that angle equal to 1/2? Just looking at this picture of the triangle that I just drew. Remember, cosine is adjacent over hypotenuse. So which angle is adjacent over the hypotenuse is equal to 1/2?
Is it 90?
It's never well, I shouldn't say it's never 90, but when we're looking at these 2 triangles, we're always going to be looking at either a 30, a 60, or a 45-degree triangle. Every one they have here, that's either a 30, 60, or 45, so is this one, so is this one, so is this one. So we're not into the quadrangles yet. The quadrangles are 90, 180, and 270. Those kind of are in a category by themselves. You kind of just have to memorize what they are by memorizing what the graph of a cosine looks like. But for each of these 4, we can find an angle in one of my 2 triangles that is the angle. And it's not 90 in any of them. So you know you only have to look at a 30, a 60, or a 45. I'll give you a hint.
So is it 45?
No, I'll give you a
Or
hint.
60?
It's in the 30-60 triangle. It's the 60. In other words, the cosine of that angle is the adjacent over the hypotenuse. So we're essentially doing it in reverse. When they tell us what the cosine of an unknown angle is, 1 over 2, we have to kind of go back and do this in reverse on how we got the cosine of this angle here. Or the second way you could do it is type into your calculator the inverse cosine of 1/2, and it'll give you 60 degrees. But you need to be able to do these manually, at least these, because these are all either 30, 60, or 45. So what's this one? What angle is the cosine square root of 3 over 2?
30.
What angle is the cotangent 1 over square root of 3?
Is it 60?
Yeah, because the tangent of 60 would be square root of 3 over 1, so the cotangent is the reciprocal of that. So good. And what angle is the tangent of theta equal to the square root of 3?
30?
No.
So then it would be 60.
Yeah. In other words, the tangent is opposite over the adjacent. All right. Same. They didn't even change the problems. Notice this says theta is between 0 and 90 degrees, meaning first quadrant. Notice this says theta is between 0 and pi over 2, first quadrant. Pi over 2 is 90 degrees. This problem 19 is identical to 23.
Okay.
25 is identical to 22. 24. Which angle is the tangent equal to 1?
Is it 45?
Uh-huh. Let's skip to 27, because we've already done 26. Solve each triangle, round answers to the nearest. Okay, these are definitely going to be calculator problems. In other words, it always turns into a calculator problem if you're not dealing with a 30, 45, or 60 degree angle or some multiple of that. You will have to undoubtedly take trig tests with and without the calculator. I'm sure. So you want to be able to do anything manually that has a 30, 45, or 60, and then problems that have a 26 degree angle is just a calculator problem. So tell me the equation that I can use to help start solving that first triangle there. We need to solve it piece by piece. We have an x side and we have a y side. So we need to solve for all angles and all sides.
Okay. So is it x squared plus y squared equals 11 squared?
It is, but that won't help you solve it, notice. You'll end up with one equation and two variables. In other words, we can't use Pythagorean theorem to solve this. Because we only have one side. The equations I was giving you for the Pythagorean theorem was given that you have two sides, you could always use the third side to solve it. But when they say solve a triangle, they mean they want to know all three angles and all three sides. So let's start with the easiest thing. What is this angle here?
Is it 64?
It's complementary to the other one. These two angles always add to 90. Now let's use some trig equations to solve for both x and y. Give me a trig equation that relates to one of these angles and a hypotenuse. Obviously can't do it using tangent. In other words, I could say tangent of 26 degrees is x over y, still got two variables in it. I can't solve a single equation with two variables. So I don't want to use the tangent function. Which one do I want to use? How about sine? Sine of 26 degrees is equal to what in our picture here? Opposite.
Oh yeah, opposite. So y over 11.
Opposite of 26 degrees is what?
Oh, I was looking x.
X over 11.
X over 11.
Now, go to your calculator and look up the value of the sine of 26 degrees, because that's the only way we have of knowing it.
It's 0.76.
Now multiply that by 11, and we've solved for x.
So it's 3.4. Or 8.4, sorry.
11 times 0.76?
Is 8.4.
Okay, now I actually could use the Pythagorean theorem to solve for y, but it wouldn't be very easy because I got a weird number there I'd have to square. So let's use another trig function to solve for y. What trig function is going to solve for y best? We can actually use any number of them now. We could use, but give me one.
Maybe cosine.
So tell me what the equation is.
So cosine of 26 is equal to y over 11.
Good. Now that's one equation with only one unknown. Take cosine 26 degrees, multiply it by this denominator, and you'll solve for y.
Okay. It's 7.12.
7.12?
Yeah.
That's the way you're going to do all these problems. In other words, on this one here, 28, we're not going to use the Pythagorean theorem because that's not going to tell us what these two angles are. How am I going to solve for angle B? Which trig function?
Oh.
Think in terms of trig functions now.
Is it tangent?
Yeah, so the tangent of angle B is equal to what?
9 point,
No, opposite over
3
adjacent.
over 9.
So
Yeah, 3 over 9.
give me that decimal.
It's 0.32.
Okay. Now how do we solve for B? If I'm saying the tangent of B is equal to 0.32, how do I solve for angle B? This is where your arc functions come in. In other words, if the tangent of angle B is equal to 0.32, you can kind of think of it as taking the inverse tangent of both sides. That may be the best way for you to think about it.
Okay.
Because when I take the inverse tangent of the tangent of B, I get B. That's what we're trying to solve for, is angle B. And that's equal to the inverse tangent of the number 0.32. Put that, solve for that in your calculator. Make sure you're in degrees, not radians, and you'll solve for angle B.
I'm still getting a decimal.
Probably are in radians. Do you know how to
Okay,
check?
do you know? Yeah, I don't know how to check.
I can tell you real quickly. Even though my calculator doesn't work, I can still see the keys. Check mode. And go down to where it says radians or degrees and make sure you're in degrees.
Oh yeah, it was in radian.
Okay? And that's how you switch back and forth between radians and degrees.
Okay.
If you're in degrees, it's not going to give you a decimal answer usually. It'll give you a...
Yeah, so it's like 17.7 degrees.
Okay, so that's 17.7. So that gives us that angle. Now we can figure out that angle by just subtracting 90 minus that. So now we almost have it completely solved. We have two sides, all three angles. We could use a trig function to solve for the hypotenuse. We could use the Pythagorean theorem. You got all kinds of things. Okay? But in general, use trig functions to solve each of these.
Okay.
Okay. We'll call it a go there. We almost got through them all. All right. Okay. Morgan, good luck.
Thanks.
Let me know if you need more help.
Okay.
Trig is mainly about memorizing. There's a lot of memorizing going to be involved. I will talk to you next time.
Okay, sounds good.
Bye-bye.